Hello there. So our last part about factoring is going to be 7.6, and these are going to be factoring special cases. And we've talked a little bit about special cases when we were multiplying. Now we want to go ahead and talk about them now that we're factoring, or breaking them down into the two things that multiply together to get your product. So I'm going to start with some examples here. And example 1 is going to be 4x squared minus 9. Now, before I go ahead and walk through this, there's a few things that I want us to notice. One is that it is a quadratic binomial. And the second thing is that 4x squared and 9 both have what's called perfect squares, meaning that there's a whole number that goes ahead and multiplies to them. So now that we're going to go ahead and look a little bit at factoring, let's start with this, is that 4x squared minus 9 can also be written as 4x squared plus 0 minus 9. And now it's set up like a trinomial, meaning that we can use some of the key things that we do when we factor trinomials, such as our diamond. And the top gets me a negative 36, because 4 times negative 9 is negative 36. The bottom goes that middle coefficient of 0. So the two factors of negative 36 that add to 0 are actually 6 and negative 6. And here's the key part, is that these two numbers here are opposites of each other. One's negative and one's positive. Meaning that when we go ahead and factor these into the two binomials, these two middle terms here end up canceling out, adding up to 0x. So using our factoring method, we know that the factors of 4x that also work for 6x are going to be 2x and 2x. And then we start filling in the rest of the puzzle here. 2x times negative 3 gets us a negative 6x. 2x times positive 3 gets us a positive 6x. So let's look at this. These are kind of the same thing, but one's connected with a plus and one's connected with a minus sign. Let's check it out one more time. I've already used blue. Let's use pink. All right, example 2 on this one. 25x squared minus 4. Things I want to point out is that 25 and 4 both have some perfect squares there. So I'm first going to write this one out as 25x squared plus 0x, that middle term is kind of missing, it's invisible, minus 4. And again, now that it's in a trinomial form, we can go ahead, we can use our diamond method, negative 100 at the top, 0 at the bottom. Those two factors are 10 and negative 10. So looking at our binomial, we're looking for those two middle terms that add to negative 10x and 10x. So factors of 25 that work for 10x, that's going to be a 5x and a 5x. Now 5x times negative 2 and 5x times a positive 2. And once again, they're almost the exact same binomials, but one's connected with a plus and one's connected with a minus. So let's try it out without having to add that middle term there. So let's try something like 81x squared minus 121. First, check for perfect squares. This one can go ahead. The perfect square is 9x, meaning 9x times 9x is going to go ahead and get you 81x squared. 121 has a perfect square of 11, meaning that 11 times 11 is 121. So using this method that we kind of see here is that we're going to go ahead and connect the first one, 9x plus 11 and 9x minus 11. Let's check to see if it worked. This guy gets us 81x squared. This guy gets us negative 99x, a positive 99x, which means that these two cancel out. And the last term is a negative 121, meaning that this multiplies out to 81x squared minus 121, which is exactly what we started with. So here you go. Here is your algebra definition. Go ahead, start here, of what we call a difference of squares. A difference of squares. And it's kind of cool because difference, of course, means subtraction, and squares are two things that when you multiply together, they get you a special product. Now, in Miss Lawrence's class, we call this a ding-dong. Now, the reason that we call it a ding-dong is because my Algebra 1 teacher taught it to me as a ding-dong, and I'm now passing on the tradition, talking about two terms connected with a minus sign. You always want to go ahead and check for a ding-dong. So, in algebra, we talk about this as a squared minus b squared. When you go ahead and you factor this, you can take a minus b times a plus b, and it factors nice and easily. So an example of this, I know we're off on our numbers, is something like 225x squared minus 49. Both of these have perfect squares. 225x squared's perfect square is 15x. 49's x squared is 7. So let's go ahead, let's factor this guy. First step first, plus and minus. Now take your perfect squares, 15x plus 7 and 15x minus 7. And that, sorry, these aren't written very clearly, is your factored form right there. Easy as that. So that's your first set of special cases, but there's one more set of special cases, and that's when we run into something like this, which is 9x squared plus 12x plus 4. So you might have seen this before. This one is pretty easy to go ahead and set up our diamond with, because we know that 9 times 4 is 36, and we know that the two factors of 36 that add to 12 are a positive 6 and a positive 6. So now, when we set up our binomials, we're looking for a 6x and another 6x. Looking for factors of 9x squared that work with 6x. That's going to be 3x and 3x. And then fill in the rest of your puzzle, plus 2, plus 2. Now, here's the part that's special about this. These two are exactly the same. They're both 3x plus 2. So how we write this is 3x plus 2 squared. And this actually right here becomes what we call a perfect square trinomial. Wish I had a special name for this. We just call it a PST. Perfect square trinomial. And perfect square trinomials are so special because they have a square to begin with, plus double your first term times your last term, plus a square to end with. So when you factor this guy out, you actually just end up with your first term times your plus your last term squared. Or if you kind of have that middle term in there where it's a minus, got to check for that guy because you might end up factoring this with a minus b squared. Okay, and the reason that we bring this up is because you will often run into problems like this. Example 4. 25x squared minus 60x plus 36. Holy moly, I do not want to set up that diamond. That would be factors of 25 times 36 that add up to negative 60. No, thank you. But let's check some things out here. This guy right up here at the front, this guy is a perfect square. Its perfect square is 5x squared, right? This guy at the back also has a perfect square. It's 6 squared. Now here's the check that you want to check for your perfect square trinomial, and this is key, is that your middle term has to be 5x times 6, that's 30x, times 2. And it absolutely is 30x times 2. It works out perfectly. So when we factor this guy, we're going to take 5x plus 6, and we're going to go ahead and square it. Or, as we would call it, right, 5x plus 6 times 5x plus 6. But please don't leave it here. Please write it like this, with that exponent up at the top. It's a binomial that is squared. Okay, I'm going to give you one more. It's going to look a little bit easier. Our last one here, hopefully you can see it. Example 5. We're going to do x squared minus 14x plus 49. Now you could go ahead, you could set up your diamond on this one, but hopefully you notice that this is a perfect squared. This is a perfect squared. And this guy right here is 7 times x times 2, but the key for this guy is that it's connected with a minus sign. So when we factor this buddy out, we got to now do x minus 7, you always connect it with that middle sign, squared. Excellent job. Those are your two special cases, a difference of squares, also known as a ding-dong, and your perfect square trinomial.